Stromboli is the most northeastern island of the Aeolian Islands, and is one of the most active volcanoes on the planet. The island is a typical basaltic stratovolcano, with persistent behaviour over the last 1400 to 1800 years. The eruptive behaviour of Stromboli is incredibly distinctive, and so the style of eruptive activity is aptly named Strombolian. The characteristics of this style of behaviour is defined by a series of discrete explosions lasting a matter of seconds, and are separated by periods of time from minutes to hours. Strombolian eruptions, typically basaltic or basaltic andesite, eject lava from the erupting conduit and can reach heights from tens to hundreds of meters. The product from these Strombolian eruptions are called tephra, and they're usually dominated by ejected scoriaceous lapilli and bombs, ash and lithic blocks. On a volcanic explosivity index, Strombolian eruptions have a VEI of 1 to 2. The active crater terrace on Stromboli lies about 750 meters above sea level, in the upper portion of the Sciara del Fosso, which is a horseshoe-like structure caused by landslides and collapses. Although persistent Strombolian activity is relatively constant, there can be significant variations over time. Effusive lava flows can occur due to overflows from the crater and interrupt the Strombolian activity. Typically, this occurs twice per decade. These lava flows can travel to the seafront and form lava deltas. It is by this process that the island of Stromboli grows, and hence is called a stratovolcano. The most voluminous effusive episodes tend to originate hundreds of meters below the craters, such as those that occurred in 1975 and 1985. Conversely, the most violent explosions are called paroxysmal eruptions. During these eruptions, ballistics are ejected from the crater, including volcanic bombs and blocks, ranging from tens of centimeters to meters in scale. The most recent paroxysm event occurred in August 2019. During this eruption, the plume height increased to 8.4 kilometers at its peak, and a mass eruption rate of at least 1.1 times 10 to the 6 kilograms per second. These are short-lived events and often involve more than one crater. Over the last 120 years, 20 paroxysmal events have occurred, with the most recent during 2003, 2007, and 2019. Passive degassing is an almost constant feature of Stromboli, from its open vents, and allows the constant outflux of volatile species. This allows the gas to build no overpressure. If the gas, however, does not have time to equilibrate with the surrounding pressure, then the overpressure will build and result in an explosion. A typical Strombolian explosion involves the emission of 40 to 150 meter cubed of gas. 77% of all gas emitted from Stromboli is erupted from passive degassing, and the other 23% from degassing during explosive episodes. The composition of the eruptive products from normal Strombolian activity and paroxysmal events can help to inform us about the volcanic plumbing system beneath the surface. During a paroxysmal event, the erupting magma is crystal pure and volatile rich, and therefore has a low viscosity. When these low porphyritic magmas erupt, they form highly vesiculated, so-called golden basalts, as shown in this image. During normal Strombolian activity, the magma is highly porphyritic, with crystal content being high and lower volatile contents. These more viscous magmas erupt to form dense black scoria, as shown in this picture here. The Stromboli plumbing system consists of a succession of magma ponding zones connected by dikes. The magma is periodically recharged by new CO2-rich magma batches across a 7 to 10 kilometer interval. During paroxysms, however, and eruptions are generated through predominantly closed-system ascent of basaltic magma from the deep storage zone. In this situation, crystallization is negligible. The change from Strombolian eruptions to paroxysms is ultimately controlled by variable pressurization of the deep feeding system associated with the magma and gas recharges. This diagram shows an interpreted model of the plumbing system on Stromboli. A hazard is something that has the potential to cause harm, whereas a risk is the degree of likelihood that harm will be caused by the hazard. The main hazard from eruptions on Stromboli are ballistic fallout. During paroxysmal events, the distance these ballistics are able to cover can easily span the entire area of the island. Lapillian ash in the erupting paroxysmal column can fall out in concentrated areas due to prevailing wind conditions. Pyroclastic density currents have the potential to destroy crops, buildings, and wildlife by traveling at great speeds at high temperatures. Wildfires can quickly propagate through the lower vegetated areas due to dispersal of incandescent material. Lava flows, although uncommon, have the potential to destroy infrastructure throughout the island, as well as cutting off escape routes for local residents. Tsunamis have been well documented throughout the Stromboli's history, with seawater able to flood up the beaches up to 300 meters inland. Risk can be calculated as the probability of a hazard times the degree of vulnerability to that hazard. Ballistic fallout onto mountain paths has a high probability and a moderate vulnerability, so gives it a higher risk. Wildfires also have a high probability and have moderate vulnerability, so plot in the same sort of area. Paroxysmal events eject ballistics into inhabited areas, but has a low probability but a much higher vulnerability, so is equally at great risk. Tsunamis have the highest vulnerability and have occurred many times, so have moderate probability, so are the highest risk of all hazards. Lava flows outside this Shara del Fujo have low probability but a high vulnerability, so are of medium risk. Some brief examples of the mitigation strategies put in place to limit the risks on Stromboli include tsunami detection systems, volcanic instrumental monitoring systems, new mountain paths and access restrictions up to 400 meters of altitude, and a new Advanced Operational Center construction which was built after the 2002 to 2003 eruptions.